All right, we're live. So
Okay, this is we're in week number 4,
lesson 6.
lesson
Lesson
6, right?
five.
Is
Oh, 6. 5 was last week. Let me get that one opened up. Hold on.
Yeah, we don't want to go backwards.
okay.
Yeah.
Okay, what we have to check is the homework, right?
Yeah, lesson 6, sampling
Homework.
distributions of the sample mean central limit theory or theorem.
Yeah.
The preparation.
Preparation, not homework.
We always do the preparation in the group work, Jose.
Okay, it's okay. I'm
just
here.
From here on out, it'll always be the preparation work.
Yes, it's okay.
All right, so we're all there.
Yeah.
Yep.
Ready. Ready.
You guys have any questions before we go to part 2? Okay.
No, not here.
Not here.
Let's go to part 2 then. So the first number 7, it's asking us to randomly select 5 of the salaries and compute the mean.
Yeah, that's right.
So I selected the second row and I just added all those up, and my mean was 45,700.
I went to the random.org and gave it its info and just picked out 5. That's what I did.
Yes, I used that website too.
Yeah, it works pretty easy.
Yeah.
Yes, what's this?
So did you guys go on the graph then and mark in the graph?
Yes, it was on the left side of the graph, my mean.
Your mean? Okay.
Yeah, 41.
Mine's pretty far on the right.
There's
On the right, okay.
Yeah.
On the right?
I got a mean.
You must have picked higher ones.
Well, it was just the random ones. I got 50,980 as my sample.
Oh, okay.
Okay, yeah.
Yeah, it was pretty high. And then I did it 5 more times, and every other one was like lower and lower and lower and lower. It just kept going down. I'm like, stop! I don't want these salaries. Keep it going up higher.
Go the other way.
Yeah.
Okay, so I guess on C it says, does your sample mean appear to be unusual? So in your case, it was unusual.
It was unusual, yes.
Mine was within 1 standard deviation.
Oh, it was, okay. Was everybody normal?
No, mine no.
No.
Yours was?
Mine was 40. Sorry, mine was 45,700. It's pretty close to the 46 in the middle, so I'm good.
Yeah.
What were your Z-scores?
Now you're gonna ask me to do some work.
So I got a little to figure out whether mine was normal or not. I took them all, input them into the spreadsheet to figure out what the mean was of all of them, and then to figure out my standard deviation to be able to get my Z-score, so we could figure out whether it was within 1, 2, or 3 standard deviations. I went a little overboard probably, but whatever.
What was the mean of all of them?
I don't remember. Let me see if I have it pulled up still.
Was it 44,880? Nope.
1 sec. Let me see. I don't have them all pulled up anymore.
So how could we figure Z-score without the mean of them all?
Well, what I did was I put them all into the spreadsheet that we have, the quantitative descriptive statistics spreadsheet. I literally just punched them all in from the Word document over into the Excel document and just punched them in. It runs the mean, the standard deviation, all of it, and then I figured out what my Z-score was from there.
Cool.
Wow, you are an overachiever.
I probably went a little overboard on it, but I wanted to make sure that I was right.
Okay, so part D, it's asking us to compare everybody's, which we kind of have. And then just seeing what the samples that we drew, so we kind of went over that. any mean that could have occurred. Okay. Does anybody have questions on 7?
No.
No.
Okay.
No,
Okay,
No, no.
so 8.
Mm,
For A, I got that, I put bell-shaped and symmetrical. In other words, it would be close to normal.
Normal. Okay, that's what I got as well. B. What'd you get on B, Dan?
okay, wait. I thought we were supposed to do 8 together.
You are?
I thought so. I didn't do it because I thought we were doing it together.
Oh,
That's all right.
we can do it together right now.
Yeah. So I only started with A, and that's as far as I stopped at.
Okay.
Okay, yeah, I went on to B, C, and D.
Okay. So B, it says, how do you know that the distribution of the sample mean has this shape, which is a normal shape? So the way we know that is because it's a normal shape. So it's in the sample.
Well, because it says it's normally distributed.
Yeah.
It's
Yes, that's right.
distributed sample will always be symmetrical and bell-shaped.
Mhm.
Okay.
Okay. So C, what is the mean of the sampling distribution of sample mean scores for all such samples?
They gave it to us.
Yes, it's the
it's-
same.
529.
529, yeah.
Okay.
Yes, it's the same.
And that's asking for the standard deviation,
Right.
So that's
which is 1. No. What was
No,
it?
actually, it's not.
No.
It's 35.734.
Yeah.
and you got that because you did the mean over the square root of the population.
Right.
Yes, number 10.
529
And the
over.
sample was 10.
So square root of 10.
Yeah, the square root of 10. Yeah, I know. I had to get my calculator out too. I was like, holy crap, what's that? I don't know.
Yeah, I'm still looking for mine. That's one standard deviation. Well, that was a heck of a lot easier than last week's, let me tell you.
Yeah.
Yeah.
All right. Should we start the quiz?
Sounds good to me.
Okay.
So let's start the quiz or the
Yeah, let's start the quiz.
okay.
All right. So let's see here. So it's telling us that we're going to need the normal probability applet.
Oh, do we need to use that?
Yep.
Wait, where is it?
They give it to us right there.
I'll give you a link to it. So, and do not round until your calculation is complete.
Good to know.
Okay, it's here. Okay, I got it.
Now I lost my page. Where'd you go? Oh,
Who?
me.
Okay, in my last group meeting, I don't know what happened. I disappeared from the conversation.
Okay. I found it.
What
Okay.
did Jose? Wait a minute, Jose, what disappeared?
What disappeared?
No. I was in another group, in another course. And then I don't know, something happened. I don't know what happened, but I logged out of the conversation. Okay, let's continue here. When you're taking with the same distribution, it's A. How do you pronounce that? Skewed, right?
It's not a very big sample size, so it couldn't be normal.
But it says
No.
When the distribution of means histogram is right skewed, the parent population.
didn't we there is a child population that's always bell-shaped?
Only if the parent population is normally distributed.
So does it mirror the parent population?
Yeah, they're asking.
I would think so.
What the distribution would be if the parent population is right skewed. So to me, if I remember from the reading, well, that would make sense. It would be skewed right.
Skewed right.
Okay,
I mean, it should still be a normal distribute. Well, no, yeah, it would be skewed right.
okay.
Because it's small. That's what it was. You said that, Matt, didn't you? Because
Yeah.
it's small, it would be skewed right. When it's larger, you get a normal distribution
Normal.
regardless of what your skew is on the parent population.
There's the
Okay.
answer to 4.
Right, yeah. So that one to me would be normal.
Because it's larger.
Yeah.
Okay.
Yeah.
Number
that's
1
what
is normal.
the reading.
Sorry. Number 3 is normal.
Number 3 skewed right.
Yeah.
Okay. Yes. Okay. We are in number 4 now.
Number 4 was normal. Yeah.
Yeah. Because it's a large number.
Larger
Right.
number, yeah.
Right.
They said anything over 30, right? Qualifies for.
Yeah. Yes.
Think so. Yeah.
30 or over 30. When you're
Okay.
picking sample size, what is the distribution?
Okay,
It's
number
normal.
5.
Number 5 is normal.
Yes.
Because the parent population is normal. So,
Yeah.
So follow the parent.
right. Yeah. When small, it follows. When it's not. When it's large, it's normal usually.
Number
Okay.
6, normal.
Yeah.
Number 5, normal. Number 6,
6.
normal.
Yeah, because it's a large population size.
Right.
And it's normal. The distribution.
Choose all that are correct.
One by one.
Yeah.
When would the distribution of means be normally distributed? Data are drawn from a population that is normally distributed and the sample size is small.
So anytime that the population that it's drawn on is normally distributed, it's going to be
Larger.
normal.
So that one is correct.
So 1 and 2,
Are they
it's
both
that
correct?
it's normally distributed and small, and then normally distributed and large. Both of those are right.
Okay.
But C is
Okay.
incorrect.
And then the last one.
Right, because again, it's a large sample size.
So 1, 2, and 4.
1, 3,
Yeah.
Okay. We have to select more than one.
Yeah, this
Yeah.
is all the correct answers. So we came up with 1 and 2 are both normally distributed, so the samples are always going to be normal.
Okay.
And-
So data. Okay. The first one, data are drawn from a population that is normally distributed. Okay, that's right. Data are drawn from a population that is normally distributed, and the sample size is large. Is true. Yeah.
yes.
Right. Yeah, anytime.
Data are drawn from a population that is right skewed, and the sample size is small. No.
No, right. Yeah.
And
Because-
data are drawn from a population that is right skewed. The sample size is large. Is
Yes.
that correct?
That is
Yeah.
correct.
Because a
Correct.
large
Okay.
sample will give you a normal distribution.
Okay. Sammy, es hora de dormir. Yes, it's go to bed. Sí, anda a la cama. Go to bed with your mama.
Control limit. Okay.
Ah, ya, guarda los colores. Okay. Number 8. Which of the following is the basic explanation from central limit theorem?
Okay, there we go.
Wait.
text. I'm deciding between 1, 3, and 4.
So 3
Oh, wait.
is large numbers.
Uh-huh.
The larger group that you have, the closer the mean will be to the population mean.
Okay.
Law of large numbers. You're right.
Right. And then the Bell data, that's in regard, that was, 2 weeks ago? A week ago?
Yep, that was last
With
time.
your standard deviation rules, the 68,
Right.
95, 99.7. So it's 4.
That's what I got.
If the parent population is on. Why is 1 not right?
So that's just saying that if the parent population is normal, then the sample will follow a normal distribution. The central limit theorem states that if the sample size is large, then the mean will be approximately normal. I'm paraphrasing, but that's what it says, and that's what I got out of the book. So,
Okay, I'll go with it.
I mean, that's what everybody else got too.
Larger
Dan,
population, more normal distribution.
Yeah, that makes
Jose?
sense.
Was that what?
In the
So-
in the reading,
So you're talking about the number, the first answer?
Yeah.
Okay,
So we put number 4 on that, Jose.
Okay, so number 8 is A, the first one.
No, it's the 4th one.
Well, it depends on what his says. What
that's
is
true.
your A? What's the statement there?
Oh, if the parent population from which the data are drawn is normally
Okay.
distributed.
No, we
No,
got
that's not.
D. If the sample size is large, the shape of the distribution of sample of means will be approximately normal. So for me, and I think Dan, Matt, Trina, that was D for everybody.
Yeah, that was D for us, for me.
E.
Okay, so if the sample size is large, that's the answer.
The last one.
The last one.
Yeah.
Yeah, okay.
The shape of the distribution will be approximately normal. Yeah.
Okay.
Okay, so here the mean is 10,
Okay. XP random variable.
and the standard deviation is and the size is 36. Oh, it's a large population on the next one.
Right.
What's the mean? 10.
10.
Yeah, 10.
The
Yeah.
answer is 10.
Standard deviation is 6. I like these kinds of questions.
Okay, the answer is 10, right?
Yeah.
Yes. We continue with number 10 now. The standard deviation of the sample mean. Okay, we have to divide.
No, it gives it to you.
Yeah, it does give you the standard deviation.
Mhm.
And that's 6.
Excuse me.
It's 10 divided by.
So on 11, it's going to be normal because it's a large group.
Right.
No matter what, if it's over 30, it's a normal distribution.
Yep.
Okay, for number 10, you got the answer because I'm not using my calculator.
It's 6. It
Well,
gives it to you.
Yeah, I give it to you.
So
on that.
which number?
On 10.
1.
6.
It gives it to you in the information. There's nothing to figure.
Yes. Okay, I have to use my calculator.
Oh wait, no. No, I won't.
well, saying the sample means not the population deviation, right?
Right. So 9 should be 10.
Okay.
I should be 10. So
10
the
won't
sample size is
necessarily be
36.
And
No.
10 is 6.
No, because remember, go back to question 8. about the GMAT on our preparation homework. So if the standard deviation of the distribution of sample mean scores for all such samples, so it wasn't 113, which was the standard deviation, it was 35.734.
It's the mean over the square root of 6.
Right.
Right?
Yep. You're right. Yep.
How do you do,
Okay,
how do you figure the square root of something?
I have a question. Let me see. Okay, sorry.
You have to have one of those fancy ones that has a square root with a 2.
So if you have a phone, an iPhone,
I've got that.
I've got an iPhone here.
Uh-huh.
Okay, Trina, I have a question. What's your answer for number
Turn it sideways.
number 10?
Just a minute.
Like that?
For number 10, I'm working on it.
Yes.
I have 10 over the square root of 6.
Yes.
And I got 4.0.
4.0.
Was I right, guys?
Um,
Oh, 4.08. One more.
4.083.
So what do? You
Yeah,
put
4.08.
4.0.
83.
Okay.
So what you have, Matt, what you'll have to do first is figure out what your square root of 6 is, and then put that in like your memory of the computer, and then do
Okay.
10 divided by memory recall.
Oh, okay.
Or just write,
Okay.
it was 2.
449.
Yeah, thank you.
So you can you put square the x2 and then 6?
Not the
Square
Well, it's not
x2.
squaring, it's the square root as opposed to putting it to the, whatever.
If you
I don't know what I'm saying.
do x2, you're going to square it. 6 times 6 is 36. You want the square root of 6.
Which is what number to get exactly 6 when you multiply it by itself.
Okay.
Okay, in number 11 is normal, right?
Right.
Yes.
And number is normal.
Okay, number 12. You are in which number are you? Sorry? Okay, let's see if I respond to the last question. Okay, large number. The law of large numbers.
Is 12 we going with law of large numbers? No, I think it's not. It's a large group, so it needs to be central limit, doesn't
I think
it?
it's central. I think it's
Yeah, the
Yep.
sample
I got
means.
First of all,
Central
because
limit.
law of large numbers is not a theorem.
Yes.
That's true too. It kind of gives you the answer there, doesn't it?
Yeah.
Central limit. No.
I didn't even catch that in the question.
I
I
didn't
just
either
got
right away.
which way did you justify it? I was like, oh yeah,
Well, chuck one up for Trina.
there you go. I didn't even notice the
Oh, that's all?
We didn't use our applet at all.
No,
Oh.
I thought for sure.
Hallelujah.
Is that good or bad?
I don't know.
I don't know. Should we submit it, see what we get?
Sure, let's do it.
Let's do it.
What do we get? Question 10, wrong.
Oh, let's go figure it out.
92.86%. I don't know if I care. And for me, it's 1 point, so I'm like, eh.
Should we just go with the guys?
But I would like to know how to do the problem though. I mean, I don't have to go back and do anything, but because obviously we just don't read the last question and find that answer.
Can we do it again?
I'll
Can we
read
do
answers.
this?
I'll
Can we
read
do this
answers.
again?
What?
9 is 10. 10 is the one we got wrong.
Yeah.
11 is
That's what we did wrong.
What's that?
Okay, so
Okay.
it's not the sample over the square root of the deviation. It's the standard deviation over the square root of the sample. We did it backwards.
supposed to be 113 over that.
Well, supposed to be 36, or it's supposed to be 6 over the square root of 36, or 6 over 6.
It's-
So 1.
You won. The answer would be 1.
Yeah.
Wait a minute. Now, tell me again what you're doing.
Okay. So we did
Yes,
it
it's
backwards to figure it. We did the sample or the mean. We did 10 over the square root of 6.
Uh-huh.
Yes.
What we were supposed to do was the standard deviation over the square root of the sample.
Yes, it won. Mhm.
So we did it wrong. So it should have been 6 over the square root of 36. And the square root of 36 is 6.
6. So it'd be 6 over 6.
So it would be
which is
6 over 6 or 1.
1.
Yes, it's one.
We did everything right. We just did the
Just did the wrong.
wrong numbers.
Yeah.
All right. You
That
ready
makes
for
sense.
the answers to do it again?
Yeah, I would, since it was that easy. I'm thinking.
Yeah.
Yeah. Every point might count.
Tell me when you're ready.
Do you guys have the answers?
I do.
You do? Okay.
Okay, you can do it again.
Number
Yeah.
3.
All right, let's see.
Well, I got to get back in the quiz.
Okay.
Food, normal. Normal.
6. Standard deviation over square root. 7.
Okay, so number 3 was Stewed, right?
You
Yeah.
right. Uh-huh.
Right.
Yes.
Good, right?
4 was normal.
Yep.
Normal.
5
Normal.
and
Normal.
5 was normal.
6.
Yes.
Normal.
Is
Normal.
Yes.
Normal.
7 is
Seven.
1, 2, and 4.
Yes. No?
Yeah,
Yes.
1, 2, and 4.
2 and 4.
Yes, 1, 2, and 4.
And 8 is D.
Uh-huh.
8, okay.
9 is 10.
This is 1.
10 is 1.
10 is 1.
1.
1 is A.
Normal.
And then 12 was central limit theorem.
Central limit
Could you tell
theorem.
How you got number 10 again? What did you do? The size of
There we
36?
100%. Okay, so for 10, again, what you do is you take the standard deviation, so your little O with the line on it,
Yes.
over the square root of n of your sample.
So because 6 times 6 is 36, that's the square root.
Mhm.
Right, yeah.
Okay, that's easy. Okay.
Standard deviation was
Square root of
6.
36 is 6, and then it's your standard deviation, which is 6, over the square root of your sample size, which is 6. So
it's
6
1.
divided by 6 is 1. That one was a really easy one.
Yeah.
We made it too hard.
Yeah, I think we
Okay,
overmade
well,
it.
it was really easy today.
All right.
So, there we go. 100%.
Works
Cool.
for me.
Good deal, guys.
All right, who's doing the video on Wednesday?
Let's see.
Actually, let me. Do I have something going on Wednesday?
I won't get home till just goes. Can I not do it, please?
No, I'll do it if you guys want. That's fine.
Okay.
I'll be
Okay.
at school.
Okay. Yeah, no, that's fine. I'll send the invite out with the link through Hangouts. So,
Okay.
You'll post this, please.
Yep.
Yes, I will. So once I stop the broadcast,
Yeah, you can stop now if
Okay.
you want.